modeling with trig functions. We're going to see word problems. The graphs of y equals sine theta and y equals cos theta can model periodic phenomena when they are transformed to fit a given situation. So the transform functions look like this: y equals a sine k times theta minus d plus c, or y equals a cos k times theta minus d plus c, where a refers to the amplitude, which is the maximum minus minimum divided by 2. K is the number of cycles and radians when the period is 2 pi. D gives you the horizontal translation, also called the phase shift. And C is the vertical translation. Y equals C is the equation of the axis. And we also know that we can get C as maximum plus minimum divided by 2. So let's try a question. A Ferris wheel with a diameter of 16 meters completes 1 revolution in 40 seconds. The center of its axle is 12 meters above the ground. The question's asking, model the height h in meters above ground of a rider after boarding the ride at the bottom of the wheel using a function where t represents time in seconds. Sketch a graph of the function for 1 period. So we have a Ferris wheel that has this diameter that completes 1 revolution in 40 seconds. The center of its axle is 12 meters above ground. We need to create an equation. Model the height means have an equation of height in meters above the ground. So it's going to be a height versus time graph, where height is the dependent variable and time is the independent variable. Height is in meters, time is in seconds. And then sketch a graph for 1 period. So let's try to understand the scenario. Let's think of it as, let's say this is ground. Let's say we have a a Ferris wheel like this, right? And it tells us in the question that the diameter of this is 16 meters, right? So that means the distance from here, the top of the, if you look over here, this distance is the diameter, which is diameter is 16 meters, okay? And it says that it completes 1 revolution in 40 seconds. So a period is 40 seconds. And the center of the axle is 12 meters above ground. So this is the center of the axle, right? And this is the ground. This is the ground, right? And this is our Ferris wheel. So this distance from here to here is 12 meters. And we know that this distance here is going to be, what's this height going to be from here? When you start if you know that the diameter is 16, that means the distance from here to here is 8 meters. This total thing is 12, so that means from here to here, this is 4 meters. So if you're trying to get on this ride at the bottom of this Ferris wheel, that means you are starting at 4 meters above the ground. So that helps us kind of create an idea, get an idea of what the graph would look like, We're not drawing the sinusoidal function here, but we're just kind of seeing where it starts off. So we see that you get on this ride at 4 meters. When you're at the top over here of the Ferris wheel, what is that height you're at? So that's going to be the 4 plus the 16, that's going to be 20 meters, right? So the maximum height is 20 meters. The minimum height is 4 meters, right? And this is kind of like our C value. Our C value is, 4 plus 8 is 12, right? That's our C value, 12. 12 meters. And then what else do we have? The period is 40 seconds. So using this, we can say that we can kind of draw a rough sketch with just this much information. We can now go to our graph and try to draw a graph. Let's scale this. It completes 1 cycle in 40 seconds. So let's say it's 10 seconds, 20 seconds, 30 seconds, 40 seconds. So this is time in, or t in seconds. And this is height, h in meters, right? And let's say this is going up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 meters. And this at the start, you get on here, and 12 is our equation of axis. So let's draw a dotted line that goes through here, which is c equals 12. Let's move that right there. And this is our c equals 12. And we have to sketch a graph for 1 period. So when you start the ride at 0 seconds, you're getting in from this point, right? And then because you are having a cycle completed at 40 seconds, you're going to have changes happening at 10, 20, 30, and 40 seconds. So from here, it's going to go in 10 seconds to this point, which is at the equation of axis. At 20 seconds, you're going to be in the top of your ride. And then you come back down 30 seconds to the halfway point where your axle is. And then in 40 seconds, come back to where you started. So you get 1 cycle in 40 seconds this way. So what is this graph model? This is a cost function, right? Which starts not at the maximum, but at the minimum. Okay, so our amplitude is this distance here. Our amplitude is 8, right? And our period is 40 seconds. Our c value, this is this y equals 12 equation, and c value is 12, and we have a negative cost function because it starts at the minimum. So find the rider's height above the ground 18 seconds into the ride. We also were asked to sketch a graph of the function for 1 period, model the height in meters above the ground using, so we have to also come up with an equation for this function. Let's come up with an equation first, looking at these values that we have here. So it's going to be y equals negative, our a value is 8, so negative 8 cosine. Our k value is 2 pi divided by the period, which is 2 pi divided by 40, which is pi over 20. So cosine, and then our c value is 12, and our d value is 0. So because pi over 20 t plus 12. That will be the equation for this sinusoidal function. Okay, so if you're asked now here, find the height 18 seconds to the ride, since we have the function, height of the function of time is negative 8 cos pi over 20t plus 12. At t equals 18 seconds, our height is going to be negative 8 cos pi over 20 times 18 plus 12, and that works out to 19.6 meters. So when you're 18 seconds into the ride, you are 19.6 meters above ground. Find the time elapsed when the rider first reaches a height of 6 meters above the ground, and use your verify your answers using the ground. So at height is equal to 6 meters, we will have 6 is equal to negative 8 cos pi over 20t plus 12. We're going to isolate and solve for time. So you have negative 6 equals negative 8 cos pi over 2t, right? You bring the 12 here. And cos pi over 2t is equal to negative 6 divided by negative 8, which is 3 over 4. Cos pi over 2t is equal to 3 over 4. And then we're going to have to solve for t. So what happens now here is we can do, looking at our graph here, we can solve for cos 9t equals to 3 over 4. 9t is cos inverse of 3 over 4. 9t equals 41.4096. And t is equal to 41.4096 divided by 9. T is equal to 4.6 seconds. And if you look at our graph to verify that, we will find that when our height of 6 meters is reached, which will be 2, 4, 6 somewhere here, right? So if you look at that, the first time it happens is somewhere here, which is what we got right now, 4.6, and then it happens again somewhere here. So this value is, this distance here will be another 4.6. So if you did 40 minus 4.6, this would work out to 40 minus 4.6, which would be 35.3 seconds. So it happens at 4.6 first, and then it happens at 35 points. So the next time it reaches that same height is at, so the first time the rider reaches 6 meters above ground is at 4.6 seconds. The second time, second time the rider reaches 6 meters is at 30, let's take 40 minus 4.6, which is equal to 35.4 seconds. Change the equation to reflect that the rider boards the Ferris wheel 6 meters above the ground. So if he is now not boarding at 4 meters, but he's changed to 6 meters, the entire graph will shift 2 units to the right. So if you look at our graph here, instead of starting at 4, his starting point is going to be over here at 6. It's going to be right here. So this point is where the graph will shift. So we will have a d value of 6. Everything else will stay the same. So our d value is 6. And since it's shifting, and that is going to be a starting point. If you look over here, change the equation to reflect that the rider boards the Ferris wheel at 6 meters above ground. So this point is not shifted to the right here. It's actually shifted over here. So when he's starting the ride at 0, this is going to be the point of starting. So instead of starting over here, it's going to start over here. So our time is going to be 4.6. Our d value is going to be negative 4.6 because you're going to shift that point right here. This is going to become our starting point. We're going to move this point over here. Okay, so our d value is negative 4.6, and therefore our equation is going to change to reflect that. Our d is equal to negative 4.6, and everything else stays the same. Our amplitude is negative 8, our k value is pi over 20, and our c value is 12. So our equation would be height as a function of time is equal to negative 8 cos pi over 20 t plus 4.6 plus 12. We're going to stop this lesson here. We can look at the example in the textbook, example 2 on page 358, and look through that example next.